Okay. Fine. Listen. Okay. Fine. Today we're going to see the second method for calculate volumes in color solution, which is called the washer method. Basically, this method is like a generalization of the previous one. Okay. Before I continue, do you know what washer means in Spanish?
Es una lavadora, es como una tuerca, ¿no? Como una.
No tuerca.
Está bien, güey.
Se le llama arandela. La arandela o rondana.
¿Qué hubo? ¿O qué era rondana?
Rondana.
Ya
habíamos pasado en de mecánica que, por ejemplo, cuando ponen un tornillo o una tuerca, pues también le vas a poner lo que es como un disquito con un hoyo en medio para que aplaste y se quede más fijo. Eso es lo que es una arandela o rondana. Si lo dibujara, ¿cómo sería? Pues como el mismo disco, pero tiene un hoyo de something like this. Okay? So in this case, for example, that would be a washer. When do you have a washer? Usually when you have a certain pair of functions, more functions, that between that function and the axis there's like a hole where there's no function. Example, we're going to see this and you'll see the difference. I want to find the volume calculated by the region y equal to square root of x, y equal to x squared, rotated about the x-axis. If I grab that, for example, would be function square root of x from 0 to 1. That's the first one, and another one, which is x squared from 0 to 1. Okay? So in this one, for example, if you observe, the area bounded by this is this one. Okay? So if I were to rotate this about this axis, the x-axis, now you have a certain part in the middle. So since you have two graphs, what happens at the end is that the rectangles that I want to put, they're not to be this anymore. They're going to be washers. So you have a part which is the function at the bottom, function at the top, the hole between that and the rotation axis, and it forms a wash. Okay? Imagine this. I want to rotate that. I put the animation again so you can see what happens. One.
¿Ese washer es tu función completa o es nomás como el disco de la pasada? O sea, que no es el disco, pero a veces lo multiplicamos todo. No creo pero me pongo la función.
Okay. This axis, this over this one. Station. And Again. Then.
A little low because of the computer, but because if you get a
More or less.
But where is the washer?
Es una.
Ajá.
Ya que no me próximo 14.
Está lenta por la corriente, pero fácil.
¿Pero dónde queda el rollo? ¿Dónde queda?
Ah, okay. There's a tip of the function indicator. That's because of the way the functions are located. But still, there's a part here in the middle that there's nothing. So it forms something like this. You form it, and that's the hole in the middle. Okay? Do you see what is happening here? Now, why is it a washer? Yes. Why is it a washer? Because in this case, for example, if this is my area, what will be the rectangle? It's going to follow the same rule as with this method. The rectangle has to be perpendicular to the rotation axis. Yeah? So in this case, my rectangle will be... Okay then, so, like I told you, the rectangle is going to be something like this, from here to here. Not all the way to the axis, but it's going to be in the middle of the graph. So, that part, when you rotate, that forms the hole that you don't have. Okay? So, before I continue with this, first, how do I calculate the volume of a washer? Normally.
Pues le sacas dos, el radio de adentro y el radio de afuera.
Yes, exactly. In this case, for example, for this washer, the total volume will be the volume of the outer this minus the volume of the inner disc, which is the hole, right? So how do you calculate that? Well, from the center of the washer, you have a big radius, the radius to the outer part. And then from the center to the hole, the rim of the hole is going to be a small radius. So to calculate the volume, then it will be pi times what? Times radius to the square times the height or the width of this. This is the width of height. Minus pi times r squared, the small one, times the h, which is the height of the washer. Can you simplify that expression? Yeah, because pi here, you can factorize that. H here can be also factorized. So at the end it's going to be pi times capital R, which is the big radius, the largest radius, minus the smaller radius, times the height.
Profe,
Ya.
¿en el quiz va a ser necesario dibujarlo pero en 3D o nada más?
No. Sí estaría un poquito tardado. Okay? If we translate that into here, into the rectangles in calculus, then the pi is going to be the same thing. But the r squared, the big R, is going to be a function. It's going to be a function, which in this case is going to be represented by the upper function. So we're going to call it now Rx to the square minus the small radius as a function, because it's the other function, times dh, which is the width, is going to be represented by what? By dx, or dy, if it's in terms of y. Okay? And that's just a single washer. If I want to find the total volume of the object that is formed by rotating that, then it's going to be now what? An integral, just like yesterday. It's going to be pi times an integral. The integral represents the sum of all the washers from A to B of the function to the square minus the smaller function to the square times dx. And that's the formula for the washer method. Okay? Do you understand that? We're going to use it in the example. Just when I'm explaining how to get the formula.
Mister, so the washer, for example, in that, is that if you slice
Yeah, for example, in this case, if I were to put this rectangle in this 3D form, then basically it's going to be like this with a hole in the middle. The hole in the middle, that corresponds to what? Corresponds to the inner part.
Ya, perdón.
Yes.
Realmente lo expresamos como una integral porque se puede decir que se hacen muchos discos.
Ajá.
Es para calcular.
Ajá, acuérdate como es que la pasada, es una suma de Riemann, es un Riemann sums. Realmente tengo que sumar todos estos discos, pero para evitarnos el límite, al infinito, todo eso, usamos la integral. ¿De dónde a dónde? De A a B. ¿Qué viene siendo A a B? Donde inicia mi área, donde acaba mi área, depende si es con un exigente. Dime.
O sea, la suma de los discos es como la suma
Ajá, exactly, same thing. But instead of areas will be balls. Yeah.
Profe, entonces, ¿no es exactamente el área? ¿Es una aproximación porque es
todo es una
No, but remember that using an integral basically represents a limit to using an infinite number of, in this case, washers. So the approximation is going to be the real one. You have an infinite number of this, or washers in this case, so the volume is going to be as close as possible as the real one. Okay. The ones that we use to find the Riemann sums, we're using just like 4 or 5 subintegrals, so that's just a very loose approximation. But this one with the integral, it means that you're using a lot of them to find the real one. Okay? Good. Our explanation, questions? No? Good. So, let's try then using this formula for this example. Okay? Here, we have the function y equal to square root of x, which is the upper function, and y equal to x squared, which is the lower function. Basically, this is an extension of the area between curves. It's the same thing. It's going to be upper function minus lower function, but you need to use this drawing, this graph, to see which one is going to be your capital R and your other one. In this case, for example, what would be all of this from here to here? the square root of x. And that represents the big radius. This one here is the small radius, and it's going to be what? X squared, and that's the small radius. So when I get my integral, the volume is going to be what? Pi integral. From where to where? From 0 to 1. In this case, the graph is exact, so you can see the limits, but if you don't see the limits, you need to intersect both graphs, if I don't give you the limits. From 0 to 1 of square root of x to the square minus x squared to the square times dx.
What are those lines that you keep?
Which line?
The black lines?
What I want is this. How high is going to be the rectangle? And that is going to be obtained by subtracting the entire big radius, which is the square root of x, minus the small radius, which is the this one. Okay? And that complies with the formula.
O sea, perdón, es que lo de arriba era súper clarito, lo de arriba fue lo de la función de la raíz cuadrada de japonesa.
Exactly. And then just solve it. Can I simplify this? Yeah, so pi integral from 0 to 1 of square root of x to the square x minus x to the 4 times dx. And then integrate that. So it's going to be pi x to the square over 2 minus x to the 5 over 5 to the, between 0 and 1. So it's going to be pi times 1/2 minus 1/5 equal to 1/2 minus 1/5 will be 3/10 units. And that's it. Okay. As simple as that. Questions? Yeah. From the graph. From 0 to 1. 0 to 1. So you need the graph. So when I give you like a pair of functions and no limits, you're going to assume that the limits are going to be given by the intersections of the graphs. In this case, you can see them directly, so fine, put them. But if you don't see them because the graph is not exact, do the intersection. Equal them. Equal this to this, isolate this. Okay. Any other questions? No? Okay, let's try example from the activity. Don't worry, we have 4 days to practice. Today, tomorrow, Friday, Tuesday, to practice either this one or the previous one. Next Wednesday, next Thursday, next week, we'll see the last one, which is called the cross-section method.
Is it here?
It's easy also. You need to remember some basic formulas for areas.
Do we have a quiz?
Next Friday. Not this Friday. The next one.
So right after we see the
Cross-section.
and cross sections coming in the quiz.
Okay. ¿Tienes mis clases?
Tiene que ver.
Sí, mañana lo que venía aquí a trabajar. Hay que necesitar plata. Ya no tengo que ir al verano. Ya tengo. Yo soy empleado de planta y no tengo que ir al verano. Pero si doy verano me pagan extra.
Ya no te queda verano.
Es que antes sí, como antes era cátedra, si no tenía verano no me pagaba nada. Pero siempre he dado verano.
Este profe, ahorita que ya tiene, que ya siempre a veces ya debe dar un brinco.
Pues la vez pasada hay dos grupos de verano. El tuyo, tu grupo y viene el otro grupo.
Si hay cálculos de verano, pero no lo voy a dar. No lo daré yo, lo daría.
Buena suerte.
Luego nos vamos a desmarcar.
Anyway, fine. Let's try number 9. It says the region bounded by y equal to x squared and y equal to 4 minus x squared rotated about the x-axis. Calculate the linear volume. In this one, for example, I need to graph both. What is this and what is that? Both are parabolas, yeah. To graph that.
No es lo que va a dar los dos y Washer.
Okay, so let's say 1, 2, 1, 2, 3, 4, minus 1, minus 2. Okay, y equal to x squared. What's the graph for that? Parabola, yeah, opening over, so it's going to be 0, 0, 1, comma 1, minus 1, comma 1, 2, comma 4. Remember, you don't remember the values, tabulate. So the graph is going to be like this. Good. That's the first one. Now, 4 minus x squared. Very good. Starts at 4, goes down, but remember, I want the function, I want the graphs exact. So from here to here, it's 1, 1. And 2, 4. So there. Don't worry, in the quiz I'm going to give you again grids with Cartesian plane, so you can graph them. Exactly. Okay. Fine. In this one, for example, what's the area bounded by the graph? Yeah, it will be just this. Okay? What's the rotation axis that I need? X-axis. So this is the rotation axis. Where is my rectangle? How is it going to be?
Horizontal.
Vertical, because it will be perpendicular to the rotation axis. It's always perpendicular. Do you know what perpendicular is, right?
Yes.
Okay. So, something like this. Something like that.
Profe, ¿qué pasa si le pongo el triangulito con el rectángulo en el medio?
In this case, nothing. In this case, nothing. Since both areas are the same, this is the upper function, lower function, no problem. But you need to be careful because there are other examples where you need to be careful where you put the rectangle because it's going to be different things. But we'll see later. What's another example? Okay. In this one, the width is what? The x and the height. Remember, the height is not a single function. There are two. All the way here from the x-axis, that's our x, which is what? 4 minus x squared. The upper function. And the one from the x-axis to the bottom of the rectangle, that's my lowercase a. It's going to be what? X squared. If you notice, it's basically the same as with the area between curves. It's the same thing. Upper function and a lower function.
Mister, but are you going to have a hole in the x-axis?
Not necessarily, because in this case you have the tip of the function that touches the rotation axis, but still, it's still Washer method because of this part.
Like a store.
According to the disk method, the whole function has to touch the rotation axis. The whole function, no holes in there. But in this case, this part. ¿Sí ven la diferencia entre el disco y el washer?
Sí.
Sí. Aunque aquí se ve que la verde toca el eje, como sería como un tipo como que de dona, pero sin hoyo, sino como que una dona, bueno, así está. O sea, algo así. Dona, pero sin hoyo, sino como que va así. Una. Es que no sé cómo es. El problema es de que hay un pedazo que no está pegada al eje de rotación. Cuando es disk method, es cuando toda la función está pegada al eje de rotación. O sea, no hay hoyos. Okay, so in this case, what will be my volume then? Pi integral from where to where?
The section of that with a node.
Yes, exactly. In this case, this is not -1. This is not -2.
1/2.
No. That's the problem. You need to get there. The graph is not exact, but even if it's exact, with squares and everything, you cannot find the value directly. You need to get it algebraically. How do you get them? You equal them. You equal them. So what do you equal? Both functions. It will be x squared and 4 minus x squared. So it's going to be 2x squared, x squared equal to 4, because this passes as plus. X squared equal to 2, x equal to square root plus minus of 2. Those are my limits. Is that 1.5? No. Not even close. So, my limits, this limit here is at minus square root of 2. This limit here is at square root of 2. So my integral is going to be from minus square root of 2 to square root of 2, and then will be what?
X squared.
4 minus x
Yeah. To the square minus
x squared
to the square times dx. Yeah? Then simplify, yeah, we can simplify. So it's going to be pi integral from minus square root of 2 to square root of 2 of 4x squared will be 16 minus 8x squared, yeah, plus x to that 4 minus x to that 4 times dx. Can I simplify? Yes. 5 16 minus 8x squared times dx. And then you integrate it. Okay? Common mistake that students do is that they think by just simplifying that's my answer. No, you need to be integrated. Okay? Por eso les pongo colorcitos. Integral en negro. Respuesta. Sí. Porque luego. No me estoy burlando, es en serio. O sea, es porque luego dicen, está burlando a mí. No, porque no quiero que lo hagan. 16x minus 8x to the cube over 3 from minus square root of 2 to square root of 2. Even better, can I simplify the process? Yeah, because if you observe the function, this function is symmetrical. So I can find just from 0 to square root of 2, find the volume and multiply times 2. So you can simplify the process if you can do it. So it will be 2 pi 16x minus 8x to the cube over 3, but from 0 to square root of 2. Do you understand what I did?
Yes.
No? Okay. Ya ven que hicimos ejemplos de áreas en los que, por ejemplo, esta gráfica, si te fijas, desde el 0 hasta este valor y ese mismo valor pero para la izquierda, ¿no? Si yo encontrara nada más esta área de 0 raíz de 2 y lo multiplicara por 2, solo tendría el área completa. Para volúmenes funciona igual. Si encontrara el volumen de esto girado, multiplicara por 2, pues ya. ¿De qué me sirve eso? Pues en lugar de poner de aquí para acá, simplemente pongo de dónde a dónde. De 0 a raíz de 2. ¿Se puede hacer eso siempre? No. Integras acá. Okay? Tell me with the answer, please. How much is that?
Voy a explicar otra vez por qué, porque
Igual.
no, ¿por qué?
¿Por qué?
Porque puse a hacer ahí.
Check the graph. Limit to limit, the same function symmetrical to the y-axis, right? We're just going to get the volume, but from 0 to square root of 2, the volume with the formula, and then multiply times 2, at the top. So I can simplify this into just from 0 to square root of 2 times 2. ¿Sí lo ves?
O sea, no sé cómo es eso y nada más vas a que sea 2.
El 2 lo pones multiplicando aquí y ya con 2 en esta vida.
Sí, ya me entendí.
It's 2 times that.
94.78.
94 point what? 78. That's an approximation because with decimals it's an approximation. Good. Questions? Yeah.
También porque si no, le iba a hacer.
No, de todos me da. O sea, esto más bien para ti, para simplificar el proceso. Porque, por ejemplo, si yo hago esta, tendría que evaluar todo con raíz de 2 menos todo con menos raíz de 2. No se cancela, se duplica. Para evitarme eso, simplemente es 2 veces esto, pero de 0 raíz de 2. Con 0 está fácil, porque el evaluar todo con 0, ahí se vuelve 0. Y al haber hecho esto con raíz de 2 multiplicado por 2, es como si quieras esto completo. Okay. Questions?
2 a mí no me dijo eso.
Fine. Try by yourselves, please. Number 10.
Profe, aquí no afecta si uno parte el cuadrado o el extra de la X o algo así.
No. When it's like this, which is between curves, doesn't matter because the minus takes care of that. Try number 10, please, on your own to see if you get the same answers. Remember that 2x, y equal to 2x is a straight line, intersection at 0, slope 2. Right over run. 2, 1, 2, 1.
Es que a mí no me da lo
Pues según yo es sencillo.
Thank you.
Dígale esta área es simétrica de 1. Tú puedes encontrar polares en vez de número de a veces 2. Pero si yo encuentro 0 a veces 2, me va a dar aquí. Pero no es simétrica. Y luego tengo que multiplicar por 2 para ver un igual. Eso sucede porque es simétrica la gráfica. Esta, por ejemplo, no puede voy. Y a veces puede cambiar. Ya sabemos que a veces está fuera de los ojos. Okay, the answer, the solution, you can check it. Should be 64, 5, or 15. Yeah. So you need to get the limits because intersections.
Sí, de hecho yo fui, nos explicó cosas a mí
Sí, porque me tiene que dar una ya con esto Yes, but it's not like that.
Ojalá, güey. Ojalá ya
Yes.